Good morning, students. Today we'll study the new topic, and topic is the differentiation of exponential function. Exponential function meaning e to the power x, and differentiation of logarithmic function. So under the exponential function we have a two kind of function, and under the logarithmic function we have a two kind of function. So one by one we'll study both. In very short we'll study that the first function is d by dx of exponential function meaning e to the power x. Without wasting the time, I am writing directly the formula that d by dx of e to the power x is itself e to the power x. Keep remember, differentiation of e to the power x is same. Second, d by dx of a to the power x. So a to the power x, how it will come? That only the question. We have an answer actually. If you want to do by the first principle, I tell you that it is f of x e to the power f of x is equal to a to the power x. So if you want to know also this answer, that how it came, so I'm telling you only this by formula. It is e to the power x. Suppose first I'm telling you f of d by dx e to the power x. So f of x equal to e to the power x, we have a function. F of x plus h will be e to the power x plus h. Why I found this? Because you know the first principle in class 11th we studied that h tends to 0, f of x plus h minus f of x upon h is here. Put up the value, h tends to 0, f of x plus h e to the power x plus h, f of x is e to the power x upon h. Now quick, I speak, e to the power x plus h can be written e to the power x into e to the power h minus e to the power x upon h. What I will do now, I will take out e to the power x common. So in both we have remaining e to the power h minus 1 upon h. E to the power x will come out as it is. So the remaining is e to the power h minus 1 upon h. And you remember that when h and h is coming here, limit h tends to 0, e to the power h minus 1 upon h is 1. So this is a class 11 concept in under the limit. So we have answer 1 and we got a formula e to the power x. Ultimately we have got the formula, the differentiation of e to the power x itself e to the power x. Keep in mind. So similarly here, d by dx a to the power x. First, don't get confused. A is number. And in that time, you please don't think that the power formula will use here. Sometimes student write x a to the power x minus 1. He or she thinks that it is power, so power will come front and the subtraction of 1 will be in the power. So don't think like that, because it is not so. This is not x to the power n. When x is here and a is here, then this formula will apply. When x is base and a is a power or n is a power or any number is in a power, the power formula will apply. But when power is x of a, so different formula will apply. Like what I'm telling you, look, suppose I'm writing here it is a. Now function will be a to the power x. Do by same method, write a here. So write a, write, you know that what I'm telling you. So this is only I'm changing all e by a, and then will get this kind of term and this kind of term. And I tell you one thing, that it is again a formula, a to the power h minus 1 upon h under the limit h to 0 is log a. It is a log a. So your answer is log a to the power x log a. So your formula now have got a to the power x log a. Keep this formula in mind. Suppose I want to give an example to you, that d by dx of 5 to the power x, what it will be? It will be same into log a. Keep in the mind the terminology, the language, that differentiation of a to the power x is same into log a. 5 to the power x, we have a question, 5 is a number. So number to the power x is same into log a. So log a meaning log 5. This is an answer. This is an answer by this formula. So we have got till now two formulas. You can understand here that e to the power x is equal to this same differentiation, and a to the power x we have this particular differentiation. Okay, let me rub this, and now I'll move on to more formulas in very short. I'm telling you. Before it, we have two formula. First, d by dx of log x log x. So this is actually in very short I'm telling you, not how the derivation now. Yeah, here the base of log is disappear. When the base of log is disappear, here the genuine base E actually having the value 2.7 approximately. So keep in only mind E is equal to 2.7 approximately, but normally only E is written, so that I'm telling you that wherever there is no base under the log, it means there is a E base. So E is exponential and its value is 2.7 something. So log x having a differentiation 1 by x, keep in mind log x having differentiation 1 by x, and last but not least I am telling you d by dx of x but with special base a instead of e. Here the base is e. When it is not written, it is disappear. When it is no base, it means there is a e base. But if instead of e, if you have supposed to like base a, like 5 base, like 6 base, like 7 base, like any number as a base, then what will be its differentiation? That is only to know. So I am telling you that how we can find this formula by viewing some few fundamental concepts. So look at here, some few fundamental concepts which will be used. Under the log with B, I am telling you all the formula with base E, not writing there. When two number coming in multiplication, we write them log m plus log n, meaning addition is separated in plus sign. When the log of m by n is coming somewhere, this separates in minus sign. When under the log of m, if you have any power n, so this n will come front, so the value of this will be n log m. So these three is very fundamental but important math formulas under the log, because this year we have a much study of the logarithmic function. That's why we should know all these formulas. Log, under the log we have m, n or 3 number may be there, so all will separate in plus. If 2 number in division, this will be separate in a minus sign. When log m to the power n is coming, this is n log m. And fourth is very important formula, I'm telling you that log, look at, suppose it is a and it is b. So what do you read it? Log of b at the base of a. Log of b at the base of a. It can be written log b upon log a. Log b upon log a, and that time its base is e. Where the no base is being here, it means it's a base e. So log of b at the base of a now can be written this. Under this, if you want to know what is its value, try to understand log ab into log ba. One can simply understand it means log b upon log a. It means log b upon log a, and it means log a upon log b. So ultimately both will cancel and answer is 1. So keep in mind again that log AB into log BA is equal to 1. So these three is actually very important. This is not in much used in this class. This also, but I have told. So now I want to know the formula of log AX. So first keep in mind that log AX meaning here the number 5, 6, 7, anything may be there. Anything may be there. So concern these two questions. Suppose question has come like that. So this will follow this formula because A is here. A is here. If it is nothing there, it is log x only. So it will be same log x, 1 by x. So this is the difference between the questions. Okay, now I don't want to waste time. Come here first. Log ax. I want to find the answer. So how can I find the answer? Okay, I tell you. D by dx of log x and base a, I want to separate by this formula. And the formula is log b upon log a. So I'll write that log x upon log a. Log x upon log a. One should know that log a is a constant value. So log a will come out as it is. And d by dx of log x remaining. D by dx of log x is 1 by x. So write here 1 by x. You can say that it is a formula, but it is not looking good. So I want to make little change here. Would you think that this is a 1 by log a? I ask you one question that log a, this is log a. What is the base here? It is e. I ask you one more question that What is its answer? Log EA into log AE. Log AB into log BA is equal to 1. So log EA into log AE is equal to 1. 1. So what is 1 by log A? So where is the 1 by log A? Can I write 1 by log A? I transfer here, and what the answer being? Log AE. Log AE. I'm writing. Log AE. Would you think that I have written correct? 1 upon that only transferred equal to log AE. What do you think about this value? This and this are same. Look at. This is log A, this is log A. Base E is genuine. You can write, you cannot write, no matter at all. So 1 by log EA is equal to log AE. I will write here. So what formula finalize we do? D by dx of log AX is equal to, it is 1 by X. Here it is 1 by X. 1 by log A is equal to log AE. So I will write log AE. So now this formula has been finalized, that whenever here is any base coming, you have to use this formula. Now I put an example for you. Suppose you have a formula, you have a question log 7x. What you will reply? You will reply same, 1 by x log AE. What is A? 7. So your answer is 7E, and that's an answer. That's an answer. So with the base of these formulas, I have actually, this was a major formula here, and this also. With these two formulas, I have explained that d by dx of log AX is equal to this one, 1 by x log AE. So keep remember, these two will come very often. These two will come very often. E to the power x have a same differentiation. Log x is equal to 1 by x differentiation. A is very important, very powerful. A is any number, and here is also A is any number. So please keep remember, these two may come suddenly, may come in any question suddenly. You should remember. So this was a very important board. You please watch 2 or 3 times. I think you can get it easily. Okay. Now let me move on some other concept. For the next 2 exercises, we are prepared now. We are prepared. I have yet to tell you 3 more things. So look at them. And these are the very important formulas. Please keep remember them. Okay. Now, students, you know function of function. You know the property function of function, how to differentiate function of function, how to make the chain, and chain rule, you know it very well. So as we know about the chain rule, also in logarithmic function, in exponential form function, we have to use the chain rule. How it is so? Let me explain something. You now know e to the power x equal to same. You now know e to the power x have a differentiation same, but instead of that e to the power x, if I write sin x, so you have to make a simple chain. Like first function is e, second will be sin x. Here there is no chain because it is only e to the power x. But instead of x, if you suppose to get any function, it will be chain rule. Like e to the power sin x. So what you will do? Definitely same chain rule. First I will differentiate to e. So differentiation of e is same. So differentiation of e to the power sin x will be same. But it is not enough. You have to do the again differentiation of new function sin x. This is not, I think it should not be new for you, because chain rule we already have studied a lot of time and lot of questions we have done till now. So e to the power x are differentiation same. E to the power sin x is nothing changed, but only x has become now sin x. So we'll do by the chain rule. First I'll differentiate to a. So e will be same. So same meaning same, and then do again of sin x. Now the question, the answer is in front of you now. D by dx of sin x is cos x. Okay, one more question I want to raise here. D by dx of e to the power, suppose cos x. What do you think about? How many functions is appearing? 3 functions. First is under root function. You remember that d by dx of under root x is 1 by 2 into same. That only I have taught. So here first function is root function. Second is e function. Third is cos function. So do by same method. First root function. What is the definition of root function? 1 by 2 into same. Right here. 1 by 2 into same meaning same. Whatever it is, same. And then do again of differentiation e to the power cos x. That's simple. Now I'll do the same. You know the method now. Nothing change here. E to the power cos x. First I'll do the differentiation of e will be same. Same meaning as I did here. Same meaning same. And d by dx of again cos x. You know that differential cos x is minus sin x, and answer. So this is a procedure. And as I taught you for e to the power x, it will also follow for log x or something here, which I write now. Way to write all the things here. Like suppose you have a d by dx of log of sin x. How you treat it? So you don't worry about this is log of something base e. Where is no base, the base is e. Where is no base, the base is e. So what is the differentiation of log sin x? So first it will be log and then second sin x. So what is the differentiation of log x? It is 1 by x. So it will follow same. But it is x now, and instead of x we have a sin x. It's a chain. So first will be log and then second will be sin. So what is differential of log? 1 by x. So what is the differential of log sin x? 1 by sin x. But not enough. We have to go the double differential of sin x. Here it is not needed because it was x only. But it is instead of x, if you have a sin x, you have two functions. First is log and then sin. So differentiation of log is 1 by this and then d by dx of sin x. And you know that it is a cos x, and answer front of you sin x, d by dx sin x is a cos x, and answer cos by sin is cot of x. That's the answer. So hope till now you have got the condition that function of function also will be applied here, chain rule also will be applied here. You have to make the habit to make this kind of question. So look at, we have a few question in exercise. We can see we have example 29. Suppose I am telling you few question of example. First, suppose question is coming e to the power x minus x, suppose. Second question is coming y is equal to sine of log x. Third question is coming, suppose cos inverse of e to the power x. And fourth question is asking here e to the power cos x. So all questions are very familiar question, but now it should be in your habit that what is differentiation of e to the power minus x. So d by dx of e to the power minus x will be, say, two function. Why? Because it is not x, it is minus x. So definitely it is a different function. So first will be e and then second will be minus x. So what is the differentiation of e? Same. You know that d by dx of e to the power x is same. So the function e to the power minus x have a same differentiation, but it is not enough. We have to go with d by dx of minus x, that new function. And you know it now, e to the power minus x is minus 1. So your answer will be like that. This is answer. This is answer. What do you think about here? Right now, I have taught this. Sine of log x. So dy by dx, how to deal this question? D by dx of sine of log x. First function is a sine and second is a log x. First function is sine and second is log x. So first is a sine, meaning we have a cos. Differentiation of sine is cos of log x, and that angle is log x. Sine of log x. So first is sine, second is log x. So first sine, the differential sign is cos, and again differentiation of log x will be cos of log x, and differentiation log x is 1 by x, and that's an answer. That's the answer. So try to have it to make this kind of question. Suppose we want to do this question. Look at, this is cos inverse of e to the power x. What do you think? First will be cos inverse, second should be will be e to the power x. And you remember that what is the differentiation of cos inverse? This is a minus 1 upon 1 minus this square, meaning x square. So instead of x we have a e to the power x. This is so. And again differentiation of what will come, e to the power x, because it is not x, it is e to the power x. And the answer is in front of you now. 1 minus e to the power 2x will be there, and e to the power x have a differentiation same. So your answer is e to the power x upon 1 minus e to the power 2x. This is an answer. So hope student, these 4 questions, 3 questions you have made. The last question is again very easy. So you can simply predict that for the answer is what? E to the power cos x. First will be like look here, y is equal to e to the power cos x. Question is here. Do dy by dx is equal to d by dx of e to the power cos x. So two functions we have. First is e and second is cos x. So differentiation of e is same. Differentiation of e is same, and do again differentiation of cos x, and the differentiation of cos x is minus sin x, and that's the answer. So these are the simple example I made. Now we will go on exercise 5.4, which is all over very easy exercise. I tell you few questions from the exercise very quick, but the work is on you guys. You have to make after understanding all these concepts and few example. Hope you are in condition to make these questions. So okay, no matter at all, within a 5 minutes. Look at questions. Exercise 5.4 we have. We have some questions. Fourth one, I'm telling you fourth one. This is a question. Y is equal to sine of tan inverse e to the power minus x. So first you should count the number of functions. First is sine, second is tan inverse, and third is e to the power minus x, and fourth is minus x. So first is sine, tan inverse, e and minus x. Four functions we have. So we don't care about functions. d by dx of this. First will be sine. So what is it? Differentiation of sine, cos. Again differentiation of tan inverse, this. So this will be same till end. And d by dx of tan inverse is 1 upon 1 plus x square. X square. This is the formula. Tan inverse having differentiation 1 upon 1 plus x square. X is this. And again differentiation of e to the power minus x. So cos of tan inverse 1 upon 1 plus, these two will be e to the power minus 2x, no matter at all, and d by dx of e to the power minus x have a two function. First will be e. So e will be same, and again differentiation of minus x will be minus 1. So overall I'll count cos of tan inverse e to the power minus x upon e to the power minus 2x into e to the power minus x into minus x have a differentiation minus 1. So minus 1 I am writing only here. So this is a solution. Very easy, not tough, but just make a habit to make this question. So we have a question number, suppose 7 I am doing. Root of e to the power root x. This is a question. How to make this question? d by dx of this. How many function we have? First is under root function, second is e, third is under root x. Three functions we have. So first do the big under root. So you know that under root have a differentiation 1 by 2 into same. 1 by 2 into same meaning same, all will come. And d by dx of now this function, because first have done. Now 1 upon 2 into e to the power x I am writing here, and d by dx of e and then under root x. So you know that differential of e is same, but it is not enough. We have to go with the differential of root x. And last answer I am about to write here, that d by dx of root x is 1 by 2 into same, and whole just merge them by all the way. It is your answer. Like upside is only this, and 2 2s are 4 x, and e to the power x will be your answer. So this is an answer. So students, this is the simple exercise 5.4. In question number 9, use a division law. In 10, just function of function. In 8, function of function. All are so easy question. So 5.4 now I won't discuss. You do. If you are not able to make the question, you can send your problem on my WhatsApp number. Thank you.